Hello everyone, hope you are doing well. Today we are gonna talk about problems related to semi-permeable membrane (SPM). So what's a semi-permeable membrane? So we'll write definition for it. A semi-permeable membrane is a thin layer of material that allows certain type of molecules or ion to pass through it. So a semi-permeable membrane is a thin layer of material that allows only certain molecules or ions to pass through it while blocking others. So certain type of molecules or ions are allowed to pass through a semi-permeable membrane. So we wrote the definition for it here. Also it blocks other type of molecules and certain type of materials are only allowed to pass through it. Now we'll solve a problem here. In a 1 meter long cylindrical container, a SPM which allows S2 to pass through it is present at a distance of 40 cm from left end. S2 gas which is 10 moles is present to the left side of SPM while O2 4 moles is present on right side of SPM. When equilibrium is attained, what will be the number of moles of S2 gas present in left side of container? So here we have a 1 meter long cylindrical container, right, and temperature is constant here. I forgot to mention in the problem. So this is the container and SPM is present 40 cm from left end, right, and it allows only S2 molecules to pass through it, right. S2 gas will pass through it and S2 gas is present in the left side of SPM while O2 gas which is 4 moles is present on right side. So this is S2 which is 10 moles on the left hand side of SPM while O2 which is 4 moles present on right hand side of SPM. So when equilibrium is attained, what will be the number of moles of S2 present in left side of container? So we'll write that at equilibrium what will happen, the pressure of the gas for which SPM is permeable should be same on the both sides. So this is what we mean. What will happen at equilibrium? The pressure of gas for which the semi-permeable membrane is permeable should be the same on both sides, right? So here the SPM allows S2 gas to pass through, thereby the pressure of S2 gas at equilibrium on left hand side should be equal to pressure of S2 gas on the right hand side of SPM at equilibrium. So P of S2 on left side should be equal to P of S2 on right side at equilibrium, right? So now we'll again draw the container and solve this problem. So here is the container, cylindrical container with SPM present at 40 cm from left end and the SPM allows only S2 gas to pass through it, right? So this length is 40 cm whereas this length, the left length is 60 cm, right? So temperature is kept constant, right, and here we have S2 gas and here we have O2 gas. When SPM allows the S2 gas to pass through it, so S2 gas will also be present on the right hand side. So let's assume that what we have to find out, what will be the number of moles of S2 gas present in left side of container. So let's assume at equilibrium the number of moles of S2 gas present on left side of container is X. So we'll assume it as X and then solve the problem. So let's assume at equilibrium number of moles of S2 gas on left side to be equal to X, right? So here it is X moles. So what will be the number of moles of S2 on right side? It will be total minus X, so 10 minus X. Similarly for O2, since it hasn't moved to left side, so it will remain the same. O2 on the right side will remain as 4 moles. Now we can solve this problem simply by using this simple funda that pressure of S2 on left side should be pressure of S2 on right side because the SPM is permeable only for S2 gas. So PS2 on left should be equal to PS2 on right. So we can solve this. So PV is equal to nRT, right? So P will be nRT divided by V. Temperature is constant, volume will be area multiplied with the length, right? So here moles is X multiplied by R, which is constant, multiplied by temperature divided by what will be the volume. It will be area multiplied by length for cylinder here. So volume is equal to area multiplied with this length. For left hand side the length will be 40 cm, whereas for right hand side it will be 60 cm. A multiplied by 40, here it will be 10 minus X. We are only taking the pressure for S2 on right side, so 10 minus X multiplied by R multiplied by T divided by what is the volume, A multiplied by 60. On solving we'll get the value of X, so 6X will be 4 multiplied by 10 minus X, so X will come out to be 4 moles, right? So this is our answer. This will be the number of moles of H2 gas present in left side of container at equilibrium. Moles of H2 present on left side of container or left side of SPM.